My name's Geraint North. I work with the HPC Tools team in Manchester. I'm going to just give a brief overview here of the work that ARM is doing around both open source and commercial HPC tools. These are based on some slides that Chris Goodyear presented at ISC this year, but I've kind of updated it. There have been a few kind of exciting announcements and developments since then, and not just the lowercase ARM logo, which has actually been the bulk of the slide updating effort. So I think it's always helpful to start kind of reflecting on what ARM's role within HPC actually is. So, you know, the business model of ARM, we are an ecosystem of competitors. We license our CPU designs from others. We license our architectures to people who do their own chips. And so what's ARM's role within here? And really, first and foremost, specifically within HPC, our role is to provide continuity. So part of the key value proposition of ARM in HPC is this promise that you now have choice of vendors, that you can target a particular software ecosystem and you could have the freedom to move between different hardware implementations in the same way that have been enjoyed by the mobile market for many years. And as a vendor of a SoC in HPC, the barrier to entry is lowered because you have a rich ecosystem of software already available for you. So ARM's role here within this ecosystem is to make sure that everything looks consistent and ARM is not weird within HPC. So whichever ARM chip you pick, whatever you want to run on, we need to make sure that you have an experience that's not only consistent across the different ARM SoCs, but is also consistent with the experience that you would get from our partners. Not from our partners, but also from our competitors as well. And there's two ways that we really address that. One is through community. So we do a lot of open source development work, and that's what I'm going to talk about first and give you an update on some of the developments there. And then the second thing we do is through consumability. We provide commercially supported, tested, and integrated tools so that if you want to get started quickly, if you want something where you can pick up the phone and get some help with what you're doing, we provide that whole set of tools for you there as well. Brief update on, I guess, a couple of European developments. We're going to hear from the Mont Blanc folks and the GW4 folks later on today. These are the serious ARM HPC deployments coming in the short term. We're also going to hear from Fujitsu, Riken, Sandia about some of the developments in Japan, in the US, in some of the later talks. So on to open source. So the first thing I just want to update you on is OpenHPC. So OpenHPC is a community-driven development to provide a set of standardized, built, and tested packages for HPC. So HPC has some very specific requirements above and beyond what you would normally get in your Linux distribution. So OpenHPC provides sort of pre-built RPMs for all of those common packages. So we've had ARM support there for a while now. Since ISC, the 1.3.2 release has just come out. So the packages being built on ARMv8 for CentOS and SUSE. We have ARM machines as part of the continuous integration, and also since ISC, Lenaro have also been doing a lot of great work around actually testing the ARM builds and actually working on the addition of various new packages. So I know a fair number of you are evaluating OpenHPC. I encourage you to pick up the new version and give it a go. And then the other kind of initiative that we kicked off at ISC was this concept of a web-based resource for sharing best practices around ARM in HPC. So this got set up, and there's been some fair activity there. I really just wanted to kind of scan through a few pages just to kind of show you what's up there and what resources are available. So this is the address here, and from this is the sort of jumping-off page from which you can get to all these other things. So we have an ARM HPC mailing list. There's about 50 members joined up at the moment. It's predominantly actually been used by us, ARM, to broadcast various updates on what we've been doing, draw people's attention to various news items, ask some questions of the community. But I'd encourage you to use this. We're very much looking for more people to ask us questions, because we get asked a lot of questions one-on-one and privately, where we think we would actually like to be able to answer them more kind of in a public forum, so that can help other people as well. So trying to encourage as much discussion that can be done in public to happen in public on this forum. And the other thing we have is there's also now an ARM HPC packages wiki. So this was kind of originally seeded by my team and has been augmented by others. that basically captures best practice around all of the HPC packages that we've heard of, what's known to build on ARM, what builds with the ARM compiler, what builds with GCC, how you build it. If you need any patches to build it, we've been dropping those in there. So you see there's a sort of a list. You can categorize things. So this is actually a category of all of the GW4 kind of Eisenbard key applications. So you can filter and search by various criteria, see what they are, see if they're known to require patches, see if they are known to build on the ARM compiler and GCC or not, and so on. And then for each package, we'll sort of call out sort of various categorizations and labels of it. And then in the case of many of the packages where it's necessary, we also post a patch or a script that you can run that builds that open source package the way that we've been testing it. So it's a great way of kind of getting started with a particular package. I'd encourage you to check this site first before you go off and build it. And anyone can contribute. So if you have patches, if you have things that you want to share around your experiences of building these, or even just to kind of ask questions or raise notes associated with the packages, please feel free to stick stuff up on there. It also has a management-friendly option. You can download it all as an Excel spreadsheet. So if you actually want to have a dashboard-type view of what's known to build and so on, you can do that too. Okay, so that was a quick update on open source. We're going to talk now about the commercial tools that we support within ARM. And really echoing that consumability message earlier, this is kind of what we aim for with our commercial tools. It has to be broad. We want you to be able to come to ARM and get a consistent, well-tested set of tools that do everything you need to do with HPC. Which means today the compilers, the libraries, we also have the linear debuggers and profilers now within that portfolio. We do a lot of work tuning for ARM cores, so not just for ARM's own designs, but we also tune for the cores of our partners as well, so from the likes of Cavium and Qualcomm and so on, where we have access to the hardware, we're able to do some tuning for those platforms. And of course, we provide the commercial support models as well, where you actually have contact directly with kind of the engineering team, with our professional services team to help you out with whatever you might need to do to get started. So, kind of what we have here. So we have C, C++, now Fortran Compiler. So we announced Fortran at ISC, and as I'll say in a minute, we've just announced the sort of second version of that. All of our toolchain is based on Clang, LLVM. We use the Flang project, which is the NNSA-funded work to have PGI open source their Fortran front end. We've been working with them to kind of take that, and that's now forming the basis of our compiler. So our Fortran compiler sort of feels a bit like the PGI compiler when you're using it. We target all of our new features into our commercial releases, but there's nothing that we hold back from the community in terms of upstreaming. It's just a matter of time. So the latest and greatest optimizations and so on are always available within our compiler, but we also have a fairly active effort in the community to push all of these features upstream eventually. And this includes, actually, I mean, the main delta at the moment is support for the scalable vector extension. So the wide vector architecture coming for ARM. This has been well supported for a while in our compiler. It's a fairly big effort to get it upstreamed into LLVM, so that's kind of ongoing. And then we also package our own OpenMP runtime, again, based on the LLVM runtime. And the same model applies there. We've done some fairly aggressive tuning to allow it to scale for large core counts. I believe all those patches are actually now upstreamed into the community. So this is pretty much just currently what's available upstream. Our ARM performance libraries are BLAS and LAPACK and FFT implementations tuned for both our own cores, so A72s, A57s, A53s, but we actually also tune specifically for our partner cores as well. So there's ThunderX and ThunderX2 tuned versions of those libraries also available in the downloaded package. Say a little bit about performance. This is our kind of percent of peak as measured on a ThunderX2 single core. Red line is us. The blue line is kind of OpenBLAS, and then this is the sort of 56 thread version. You can see here once you've given it enough work to do that it can spread the work across 56 threads. We're able to get pretty decent scaling performance. Kind of ThunderX2 tuning is really the kind of focus of my team over the next few months. That's where we're kind of really doing a lot of our work and targeting a lot of our performance optimization efforts. In terms of what's new in ARM compiler, we have new version of the performance libraries just released. So HPC, the ARM compiler for HPC 1.4 is the package that includes the compiler and the libraries. So the ARM performance libraries now support linking against GCC 7.1, and will also link against ARM compiler produced binaries as well. In terms of changes to ARM compiler, a lot of this has been usability type work. So part of what we've been doing with all of those open source packages is basically ensuring that they don't only build with GCC and Fortran, but also build with the ARM compiler as well. And in doing that, we've started to identify all of those common flags that people kind of assume the existence of when you're building with Fortran. So although we support a lot of the PGI flags, because Flang is based on PGI, we've also been adding the appropriate aliases for the Fortran flags to try to make that process of adopting the ARM compiler as smooth as possible, where these flags will kind of work for you out the box. The other new feature we've added is a -m CPU equals native flag, and what this does is it basically does microarchitectural tuning for the platform on which you are currently building. So again, what was difficult is when we're trying to recommend this is the way that you build a particular package, we had to say, but there's a -m CPU equals ThunderX CN99 flag that you have to pass in if you're building for ThunderX. If you're building for something else, you have to pass in a different flag. So the compiler now supports this mCPU equals native flag. It'll look at your proc CPU info. From that, it will infer what kind of chip you're building on, and then will automatically switch on the appropriate optimizations for that chip. One of the other things we have, this is currently an undocumented feature, but let me know if you're interested in evaluating it. We actually now have support for a vector math library. So we have a math library based on an open source project called Sleef. Basically lets you do your sines and your cosine type functions where you pass in a whole vector of data and get a vector of cosines back. This allows our auto-vectorizer to be more aggressive because we can now auto-vectorize loops that contain functions, square roots, these sorts of things. So we have this in as an experimental feature. If it's something you would like to play with, let me know. I have my business cards that I'll leave there if you want to get in touch. The main reason we're not really documenting it is we want to sync with the community on what the command line flag should be to make sure that we're consistent with community LLVM when we do this. We've not yet done this, so we don't want to sort of shout too much about exactly what this flag is because we don't want to annoy people by changing it later on, but the support is definitely there. And we've done some work on the packaging side as well. So previously, when you install our tools, you get a whole bunch of module files already set up to work for you. They weren't compatible with LMOD, which is what OpenHPC uses as its kind of modules manager. So we've made sure that all lines up and works. So you have a good experience when you're using this in conjunction with an OpenHPC derived build. And then alongside the kind of commercially supported tools, we also have a suite of experimental tools. So we have the ARM HPC compiler, and by the way, you can download evaluation versions of the compiler and the library directly from the ARM website. But for people who are evaluating new architectures, and specifically SVE, we need a way that you can take the binaries that you've built with SVE and then actually run them on a system, know that they're functionally correct, and ideally perform some kind of analysis as to how those binaries are performing. So we have ARM Instruction Emulator. So ARM Instruction Emulator runs natively on your ARM system, and it basically traps and emulates any illegal instructions that it encounters. So you can use our compiler to build a binary that includes SVE instructions. You can run it on your ARM system through ARM Instruction Emulator, and you'll get a functionally correct but not performance accurate run of the system as if you had SVE capabilities in hardware. And then kind of at the far end here, we have a tool called Code Advisor. Code Advisor is a web-based UI for presenting really the outputs of what the compiler could or couldn't do, prioritized based on where ARM Instruction Emulator saw you spending your execution time, so that you can actually see for your individual loops annotated in your code, this loop was vectorized with SVE instructions, I couldn't vectorize this with SVE because, and actually provide you with some insight into why your code was not suitable for vectorization. It has a bunch of other things. It notices if you're compiling with O0 and these kinds of things, so it can kind of point out some sort of common things you might be able to fix to improve the performance of your code. And this is kind of very much under development. One of the things we'll be doing shortly is the plugin that generates this kind of advice in Code Advisor. We're actually going to move that into the kind of compiler package so that when you get it, so that we're able to ship new compilers with new versions of Insight, and you'll just be able to get those new messages kind of straight up there in Code Advisor. As it is today, we have to kind of release them in lockstep to kind of keep that in sync. And again, ARM Instruction Emulator, ARM Code Advisor, you can just download them for free from arm.com and use them today. So new in ARM Instruction Emulator. So again, experimental feature, thanks to Chris and Miguel for their kind of input in this. This has really been done in support of some Mont Blanc 3 work, where you can basically integrate the ARM Instruction Emulator with Dynamo Rio, the binary instrumentation tool, and use it to produce a sequence of memory traces. So all of your memory accesses, both the scalar and the SVE and the neon instructions, you can get a single trace that kind of shows you where all your loads and stores were, understand some of the complex operations like the strided loads and the scatter-gather operations and so on. So again, if you want to try out this feature, get in touch with me. We're able to kind of make deliveries to this, show you which versions of Dynamo Rio you need to integrate with, and provide you with scripts and so on to make it work. I think once we get this firmed up, this is the kind of thing I'd like to see more of in ARM Instruction Emulator, that really in the first iteration it's been there to just allow you to check for the functional correctness of your code, make sure you can compile with SVE and get the right results. But the path we're really on here is to provide more of this kind of analysis, because that's what people really want to do with SVE as soon as you've kind of got to the point where your code is working well. Just kind of finally, a quick shout out on the ARM Compute Library. So this is an open source library really targeted towards computer vision and machine learning. So this doesn't come out of my team. This comes out of a separate group elsewhere in ARM. But I just wanted to kind of draw attention to it because there's often a bit of confusion because of their similar names. So what the Compute Library is it's a focus on computer vision, machine learning. It's tuned for both ARM cores, but it also has offload to the ARM Mali GPUs using OpenCL. In terms of functionality, the overlap they really have in common with the ARM performance libraries is that they both have a GEM implementation. Difference being that these are really focused on small matrices, they have offload onto the GPU, so if that's the kind of thing you're looking at doing, these are probably more appropriate. The GEMs in the ARM performance libraries are parallel and they're focused on a range of problem sizes up to the very large. And then just finally, a sort of mention of our software grant program as well. So for folks who want, who meet the appropriate criteria, as you can see here, we can provide commercially supported tools free of charge for people who are kind of getting started with ARM, who are doing those initial porting efforts and so on. So again, grab a business card and get in touch if this is something that you would like to sign up for. So that's me. Quick summary, really just saying everything that I've already said. I will leave it on that slide and finish there. So thank you.